2.4 is on molarity as a part of foundations in chemistry part 2. We're looking at the outcome FC2, constructing an understanding of the mole as a unit for measurement as the amount of substance. We will learn how to calculate concentration of a solution to mole conversions and how to calculate volume to mole conversions. A solution is a homogeneous mixture of two or more substances. Remember, homogeneous, you can't tell the difference between, if you're mixing salt and water, you wouldn't be able to see the salt, whereas if you mix sand and water, you would be able to see the sand in your water. That's not a homogeneous mixture. A homogeneous one would just look like a single mixture. And the substance present in the largest amount of moles is referred to as the solvent, and the other substances present are called the solute. The substance that dissolves in a particular solvent is said to be soluble in that solvent. If we have water, and you have some sort of salt dissolved in the water, often the water is the solution, and when water is the solution, it's said to be aqueous. Whenever you have salt dissolved in water, remember from last unit that the solution is said to be aqueous. The concentration of solutions, or molarity, which is a big M, or molar concentration, is defined as the number of moles of solute per liter of solution. So if you have lots of moles dissolved in some water, it would have a high concentration. If you have only a few moles dissolved in water, it would be a low concentration. So if you put like 8 scoops of iced tea in your glass of water, you might have a very high concentration of iced tea, whereas if you put half a scoop in your glass of iced tea, or your glass of water, it would have a low concentration of iced tea. And a concentration that expresses the moles of a solute in 1 liter solution, so that's molarity. Molarity, also represented by a big M, which is very important, is moles of solute over 1 liter of solution. If we had a 2 molar solution, 2 molars of hydrochloric acid, it would be 2 moles of hydrochloric acid in 1 liter of solution. 1 molar of hydrochloric acid, 6 molar of hydrochloric acid is 6 moles of hydrochloric acid in 1 liter of solution. A solution of 3 molar of sodium hydroxide, if we want to write the molarity in the form of conversion factors, we could write 3 moles of sodium hydroxide over 1 liter of sodium hydroxide solution, or we can reverse or flip that conversion factor, 1 liter of sodium hydroxide solution over 3 moles of sodium hydroxide solution. So very similar to our molar mass or gas conversions, or any of these conversions, we can write them either way. Our example here, a potassium hydroxide solution with a volume of 400 milliliters contains 2 moles of potassium hydroxide. What is the molarity of the solution? So we already said that molarity is moles over liters, and we have milliliters. So we want to make sure we can convert that milliliters to liters. Maybe I'll do that first. So 400 milliliters. Remember, there's 1,000 milliliters in 1 liter. So 400 divided by 1,000 is 0.4 liters. So we have 2 moles of potassium hydroxide. When we have 2 moles of potassium hydroxide all over 0.4 liters of potassium hydroxide. We would get a molarity of 5 moles per liter, or you can write it as 5 with a big M. Those mean the exact same thing, 5 moles per liter or 5 with a big M. Stomach acid is 0.1 molar hydrochloric acid solution. How many moles of hydrochloric acid are in 1,500 milliliters of stomach acid solution. So again, we are going to want to make sure we have our volume, and our volume is liters in liters. So we might want to convert our milliliters first. And there's 1,000 milliliters in 1 liter. If we divided those two by each other, we would get 1.5 liters because our milliliters cancels off. Now, our question is asking how many moles of hydrochloric acid are in 1.5 liters of stomach acid solution. We have two numbers here, and it's a little bit confusing. Sometimes you're like, oh, which number do I start with? I have two numbers in my question. Now, with molarity, I find it's easiest to always start with the number that is not molarity. So I would start with my volume or my liters, and then I would use my molarity to convert to moles. So if we remember, 0.10 molar hydrochloric acid is the same thing as 0.10 moles over liters. Now if we have liters on top in our from 1.5 liters, we can put liters on the bottom and 0.10 moles on the top. So our liters cancel out, and then we get to be just left with our moles, which is what our question's asking for. If we work that out, we end up getting the answer 0.15 moles. Our third example here, how many milliliters of stomach acid, which is 0.10 molar hydrochloric acid, contains 0.15 moles of hydrochloric acid. So again, going with the previous example, never start with that molarity. Start with whatever else you have in the question. So 0.15 moles. And then we can use that molarity to find our liters, or our milliliters in this case. And remembering that 0.10 molar, or big M, means moles over liters. If we have moles on top with our question, we are going to want moles on the bottom in order for moles to cancel out, which leaves us with liters on the top. Now our question doesn't want, or our answer doesn't want to be in milliliters. The question isn't asking for liters, it's asking for milliliters. We want to convert it to milliliters. We know that for every 1 liter, there's 1,000 milliliters. We want to make sure that liter's on the bottom so it cancels off. And if we multiply that out, we end up getting 1,500 milliliters. Our next example, how many grams are present in how many grams of potassium chloride are present in 2.5 liters of 0.50 molar potassium chloride solution? There's a few things we can kind of think of. If we remember, whenever we see grams, that means we need to figure out our molar mass. We also know here that 0.50 mole over a liter. Well, that'll be useful to write it that way. We can figure out our molar mass next. Our potassium. We have 1 potassium. And potassium's molar mass is 39.1. And chlorine's is 35.45. So those are both just 1. If we add them both up, 39.1 plus 35.45, we get 74.55 grams over mole. So if we take a look at our numbers, then we can use our question. We have two numbers that we could start with in our conversions. Again, we never want to start with molarity, so we start with that 2.5 liters. We need to use a conversion next, and the only one we can use is that molarity conversion. We want to put liters on the bottom and 0.50 moles on the top. And then again, it's not just asking for moles, it's asking for grams. We need to use molar mass with moles on the bottom. So our moles cancel out and grams on the top. So if we do that, we can go 2.5 times 0.5 times 74.55, and we end up with 93, just 93 grams, because we only need two significant figures, so 93 grams. And our example 5 here, a glucose solution with a volume of 2.0 liters contains 72 grams of glucose, which is C6H12O6. If glucose has a molar mass of 180 grams per mole, what's the molarity of the glucose? We have a few different things here. It gives us our molarity, our molar mass. We're looking for our molarity. But when we're looking for molarity, we're going to want to look for moles on top and liters on the bottom. Now we have a few different numbers that we could start with. And the one that makes most logical sense, so if we're ever given grams in a question, I would always start with grams and never start with molarity. So those are kind of like our two rules of conversion. So never start with molarity. And always start with grams. So we're going to start with grams here. We have 72 grams, and we start with grams. We need to use that molar mass, 180. It figured out our molar mass for us already, which is nice because that was a big molecule to calculate. And now we have 72 grams divided by 180 grams per mole. We're left with moles on top. We're looking for moles on top and liters on the bottom. So we already have moles on top. We don't quite have liters on the bottom, and if we look at our last number that we have, it's 2.0 liters. Now we can just put our 2.0 liters on the bottom, and in this case there's nothing that goes with liters. So sometimes I've scratched it out, sometimes I put a big X, whatever. Just to make you remember that liters has to go on the bottom, and if we look, we do have moles on top and liters on the bottom for our calculations, which is what we want to find the molarity. So we go 72 divided by 180 divided by 2, and we get the answer 0.20 to two significant figures moles per liter, or you can write it as 0.20 with a big M. They mean the exact same thing. Another example here, sodium hydroxide is used to open stop sinks, to treat cellulose in the making of nylon, and to remove potato peels commercially. If 4.0 grams of sodium hydroxide are used to make 500 milliliters of sodium hydroxide solution, what is the molarity of the solution? So we see that milliliters, we have to go, okay, right away. It needs to be in liters. We change it to liters, so 0.5 liters. And then we look at our two numbers that we have in our question. We know we always want to start with grams. So we're going to start with grams. And then we also know that when we use grams, we need to make sure we find our molar mass. So we have sodium, oxygen, and hydrogen. We have one hydrogen, which is 1.01. We have one oxygen, that's 16. and we have 1 sodium, that is 22.99. And if we add all those up, we are going to get a molar mass, 22.99 plus 16 plus 1.01 of 40 grams per mole. So if we have grams on top, we're going to need grams on the bottom. It cancels out. And if we remember, we have moles on top. We're looking for molarity, which is moles over liter. We already have moles on the top. We're going to need to put that liters on the bottom, and there's no pair with the liters. There's no unit pair with the liters. So we go 4 divided by 40 divided by 0.5. We get 0.2. And we need 2 significant figures, 0.20 mole per liter or 0.20 big M. Another example here, how many grams of sodium hydroxide are required to prepare 400 milliliters of 3.0 molar sodium hydroxide solution? We're looking for grams, so we're going to need to use molar mass. We've already calculated that in the previous example, 40 grams per mole. We have 2 numbers here. This one's in milliliters, so we'd want to convert that to liters. And we have our molarity, which is 3.0 moles over liter. We know we never want to start with our molarity. We start with our other number in the question, which is 0.4 liters. And then we can use our molarity to convert to moles. We now have moles. We want our answer in grams. We use our molar mass. Since moles is on the top, we had to put moles on the bottom in order to convert to grams. So 0.4 times 3 times 40, we get 48 grams. So what do you call a tooth in a glass of water? A 1 molar solution.